Good evening, guys. Welcome to the last session before your exams. So, there is something that I would like to tell you. First of all, right now in this session, guys, we are going to discuss about the important the formulas that is there in our physical chemistry. And if you are thorough with these few formulas and these few things, if you keep in mind, there is no chance of you making any mistake or you will not being able to solve a single question in here. Okay, I'm going to tell you every single details about the formulas, not only the formulas but also how to apply it, which all units to keep in mind. So sometimes what actually happens is we are very much thorough with the formulas, but as we haven't solved a single question, or let's say we are not in touch of solving the single question from that, so sometimes what actually happens is, guys, we don't really notice which all units are there. That can also cause some kind of sort of difficulties when the questions come. Correct. So I'm going to discuss about that as well. So on an overall basis, guys, this session would be sufficient for your physical chemistry preparation. The topics that I'll be mentioning right now for your numericals, make sure you go through those things, and there isn't any other topics that you have to note or any other topics that you have to look for your numericals. I'm saying, all right. Definitely for the theory based questions, guys, you have to look into the previous year question paper a little bit to understand what kind of theory based questions are going to come here. Definitions, Henry's law, Raoult's law, ideal system, azeotrope, you can understand these are the most asked questions, right? So you know to focus on that. Definitely, guys, make sure that you know examples, because there isn't any definition which is uh, you know a perfect definition without an example, right? So make sure you are always aware of which all examples you're going to put, where you're going to write what. Okay. So that was the entire idea about the theoretical questions. Right now, guys, let's start talking about the formulas that you have. So today we are going to start with the solution chapter. Then I'm going to go to the electrochemistry, and then we are going to go to the kinetics. I'm going to tell you which all questions you have to be prepared for your numerical kind topics. Okay. Now, so our question practice is it fine if we have practice the PYQs as an NCRT exercise? Arju, 100%, 100%, 100%. PYQs are good. NCRT exercise is also fine. So anyone would do. No issues with that. Okay. Sir, could you explain the minimum boiling? I would explain this, Viraj. No worry. Minimum boiling and maximum boiling as your drop. No. Okay. Just remind me of it. I'll definitely explain this part. Okay. Dhruv, for electrochemistry, na, solve the NCRT back exercise. It's better. Okay. For others, you solve the PYQs. In NCRT back exercise, there are some good questions of electrochemistry. So I would suggest you to go through that. Okay. You have the NCRT solution as well, isn't it? From askIItians, it is there. If you need again, you have my number. You can just text me in my WhatsApp. Okay. And guys, feel free to reach out to me for before your exams. Okay. I'll try to be entirely available for all of you. I might not be able to take your sessions, but I would be available over the WhatsApp. Okay, to deal with your doubts. You have all of you, I guess, have my number. So just send a picture of your doubts. I'll definitely get back to you as soon as possible. All right. So don't worry about anything regarding your doubts in here. Second, discuss about the percentage association. Definitely, Anna, I'm definitely gonna talk about that. It is in my list of today's discussion. So don't worry about that. And guys, always send the messages to the host account, okay? Not to the co-host. Just take that. Now, let's get started. Let me turn my camera here. All right. So, so those who are watching live, for them as well, just make sure you can send your doubts in the YouTube chat. Okay, in the chat section, in the comment section, I would be definitely taking your doubts as well. All right. Now, let's get started with the formulas here, guys. So I have actually looked into the type of questions again have been coming in the last few years, but mostly, there are certain things that I feel like that you guys are that there's a high chance of everyone making mistakes. And I guess you have seen there was another webinar I have taken on this topic only, which all things are there where we can make mistakes, where we are most probable mistakes can be happening in there. Okay, so we have taken a session like that as well. So I'm gonna tell you a few things in this session as well in physical chemistry, which all things that you have to be very, very prepared with when you are writing the answers. Okay, where are you most likely to make the mistakes and everything. Okay, now let's get started with it. Okay, all right, guys. Now, I guess my voice is loud and clear to all of you, right? There is a little bit of mic problems in the last session. Just check it once, guys, and just confirm that over the chat once, everyone. Is my voice clearly audible to all of you? Please quickly give me the confirmation. Great, great. Okay. Now, so guys, let's start with the step to solution here. Okay. First, when we are talking about a chamber full of gas, let's say there is a gas A and there is another gas B in that chamber. Now, the gas A is putting the partial pressure of that gas A is partial pressure of that gas is PA, and the partial pressure of the gas B is PP. So, what would be the total pressure, guys? Definitely, you would say, sir, it is going to be PA plus PB. Correct? Yes, it is true. PA plus PB. But, guys, it is only true when you have equal amount of A and B. Let's say you have different amount of A and B. Then what would happen? Then you have to consider the amount of A and B as well. So that's why, guys, we go for PAXA plus PBXB, this formula here. What is XA and XB, guys? These are the mole fractions of A and B. Okay. So if you go here, what is the way of calculating mole fractions? Definitely, guys, if they are asking for XB, then how do you calculate XB? Definitely, you are going to go like NB by total number of moles, Na plus NB. Simple, right? Okay. Now, this is the first formula for a total pressure of gas mixture. Total pressure of a gas mixture. Correct? This was the first one here. Just 1 second. Let me spotlight myself. Okay. Yeah. So like I was saying now, this is the total pressure. Now, what is this, guys? Is there anybody who can tell me what is the formula? This formula that I've drawn here, that I've written here. What is this formula for? P1 equals to Y1P, P2 equals to Y2P. What is this P? What is this formula for? Very good, Devabrat. Very good, Bhavna. So this formula is a very special formula, and very many of you might have missed it while studying. Let's say, guys, there is a beaker full of volatile substance. Okay. Now you want to find out. Let's say the substance over here, gas A. Liquid A is there. It's a volatile liquid, correct? So now, guys, definitely you know that when it is a closed system, this volatile liquid would form a little bit of A vapor there. Would be forming a little bit of A vapor. Correct. Now, this A vapor over here, this A vapor would be having some partial pressure. So what would be the partial pressure of this A vapor? How would I figure that out? The problem clear to you guys? There's a volatile liquid A. If it turns into vapor, this would definitely turn into vapor, because every volatile liquid would always stay under the liquid vapor equilibrium. So if it gets into the liquid vapor equilibrium, then what would be the partial pressure of that vapor? So what would you do? You would go like partial pressure of A would be Ya into P, and if there is another particle, then another gas, then partial pressure of B would be Yb. So like, what is Ya and Yb then? Ya is the mole fraction of A in vapor state, right, Nandita? In vapor state. So in vapor state, the amount of A that you have, in the vapor state, in liquid state, guys, we call it XA. That's the way of representing. When you are doing in the liquid, then it is called XA. Mole fraction of a liquid is called XA. And when it is in a gas, then we call it YA. That's the difference, guys. Okay. So this is the equation for us. Okay. Acha. Now let's go for the next one. Next one over here is, acha, what is this equation for, guys? Recognize it and tell me. What is this equation for? Delta H equals to 0, delta V equals to 0 in chapter solution. Very good. This equation is for ideal solution. All right. This equation is for ideal solution. If I have a non-ideal solution, then what would happen? Right? It would be delta H and delta V would be not equals to 0. Correct? Now, not equals to 0 is fine, Niril. But if I ask you, there is a positive deviation. If I say there's a positive deviation from ideality, then what would happen? Let's see how many of you can tell me. For positive deviation from ideality, what would be the equation, guys? Exactly, very good. Delta H and delta V would be both greater than 0. So similarly, guys, for negative deviation, both of them would be less than 0. Correct? Well done, guys. Now, coming to the next one here. Guys, mole fractions equation, NB plus by NA plus NB. Right? But there is more to it actually. See, when you see the questions, by the way, you know XB comes under one of the Raoult's law, right? So if I take you to that, so what is the Raoult's law? The first Raoult's law is relative lowering of vapor pressure, RLVP, relative lowering of vapor pressure. So now in this Raoult's law, it goes like, let's say PA minus, there's one thing, guys. See, the vapor pressure is getting lowered, right? So that means pure A, let's say A is the solvent. Pure A is having more vapor pressure than impure A. Acha, by the way, guys, is it clear when to use Raoult's law? Tell me, when do we use Raoult's law? What is the criteria of Raoult's law? What should be the solute? What should be the solvent? What is the criteria of solute and solvent here? To apply Raoult's law? Very good, Nandita. Solute should be non-volatile. Very good, Yana. Solvent should be volatile, right? Do you know that always solvent is given as A and solute is always given as B, correct? Now, what I'm trying to say over here is, if the vapor pressure of pure A means pure solvent, is more than the vapor pressure of impure A. Impure means, guys, A plus B, when I have the solute present on it. So it has to be more, right? That's why I'm calling it relative lowering of vapor pressure. Means when I'm mixing the solute, the vapor pressure is lowering down. So as it is lowering down, that means PA minus PA, let's call it P naught A minus PA divided by P naught A. What do I mean by this, guys? See, it is relative. Relative means with respect to someone. Whenever it's a relative property, guys, we put that someone in the denominator. So who is it relative to, guys? It is relative to the pure A component. P naught A is pure. It is pure solvent, correct? And PA is impure solvent. So when if they say calculate the value of lowering of vapor pressure, that means, guys, you're gonna find out this value. If they ask you relative lowering of vapor pressure, only then you divide it by P naught A. So just check what is the question given to you. If they're asking that, what is the value of lowering of vapor pressure? So you cannot use this entire equation, right? You have to use P naught A minus PA, not P naught A minus PA by P naught A. That is when the relative word is there. Understood? Everyone clear? That would be, what is the equation for this? Let's say Van 't Hoff factor I haven't taught you yet according to this session. I haven't taught you. So let's get rid of Van 't Hoff factor here. So what would happen? P naught A minus PA by P naught A would be XB, correct? It would be XB. Let me check. Right. There is no, if anyone having any issues in the live section, you can just put it in the comment, guys. Okay, so now this would be xb, correct? Now over here what you have to do is this xb, when you're writing the equation of xb, you might be knowing, sir, it would be nb by na plus nb, isn't it? But guys, how do you write nb and na? You write wb by mb divided by wa by ma plus wb by mb, right? Now look into the ncrt here. For this kind of question, for relative lowering of vapor pressure questions, for relative lowering of vapor pressure question, there is an approximation that they use. Okay, but be very careful while you are using this approximation. The approximation is, they are saying that number of molecules of A is always very greater than number of particles of B, means moles of B. Mole fraction of A is always, moles of A is always very higher than moles of B. That's why they would neglect it completely. And the final equation goes like wb by mb divided by wa by ma. Guys, while you are solving the relative lowering of vapor pressure question, use this equation. Don't use this equation. It is given in the ncrt to use this equation, so you're gonna use this equation. All right, when the relative or lowering of vapor pressure question comes, you are gonna neglect wb by mb here. Okay, understood? You can cross verify it from the ncrt as well. This is relative lowering of vapor pressure. Exactly Naman, exactly. Do one thing, you just check the there is one example which has been solved in the ncrt, so look into that example. You can definitely use wa by ma plus wb by mb. The answer would not be wrong. It is definitely going to be more perfect answer, right? We can use our common sense. It can be more perfect answer. But if you use only this equation, then also they have to give you marks for this. All right, so you can use this equation if you have time, guys. But if you do not have time, or if you are in a hurry or something, then definitely go ahead and use this equation. No one cut a single marks from you. Okay, acha. About molality, how do you calculate molality, guys? Molality is the number of moles of solute divided by in 1 kilogram of solvent, correct? Exactly, Naman. Exactly, so how do you write it in the abbreviated format? You write it like nb divided by 1 kilogram of solvent. So how do you write it? wb in grams divided by 1000. That also we can write. Kilogram means, if you're writing in grams, divided by 1000 is kilograms, right? You can take this thousands all the way to here, correct? So nb can be written as wb by mb, mass by molecular mass is the number of moles, into wb into 1000. So this is the equation for molality. Why do we need it? Again, if you go to the Raoult's law there, so there is the second Raoult's law, which is, so you need it in two equations, right? One is depression of freezing point, elevation of boiling point, in both the cases, right? So delta TB equals to KB into molality. In here you need it. And again, delta TF equals to KF into molality. In here also you need it, right? Both the equations you might need it. Acha, that's that. Now about concentration. C. When is this term gonna come? In the third equation, which is phi equals to C into R into T. So this C is nothing but, guys, it's molarity, right? So how do you do this? It is N by V. Molarity is number of moles in liters, total solutions, right? In liters. N by V. So you can go like WB, so NB definitely, WB by MB into V. Okay, if the V is given as ml, then you multiply it with 1000. Otherwise, keep the V in liters, so no need to multiply or anything. Okay, so these are the equations for here. Now coming to the point where most of the students are likely to face difficulties, it's the Van 't Hoff factor here. Okay, now what is this Van 't Hoff factor? First we need to understand why do we need this. See, Van 't Hoff factor is a very realistic approach. Let's say you know that our colligative property depends on the number of particles, right, guys? Now there are some particles who can break down in solution or who can associate in solution. Let's say I'm talking about NaCl. Guys, what actually happens is, let's go here. For NaCl, it's being an ionic compound, it would break into Na plus and Cl minus. So let's say you have given 5 particles of NaCl in water, and you have calculated all the colligative property questions with respect to 5 particles. But actually, guys, this 5 particles of NaCl has broken into 5 Na and 5 Cl. That means it is acting like 10 particles. You have given 5, but it has dissociated to 10 particles. So that means all the colligative property you have calculated, you have to multiply every single colligative property with 2 now, because whatever you have calculated is for 5 particles now. You have to calculate it from 10 particles. You have to multiply all of them with 2, right? Or divide sometimes as well. But my point is you have to calculate again, right? That's the erroneous calculation that you have done. So that's why Van 't Hoff factor comes into the picture here. So Van 't Hoff tells you that there are two situations. One is association, another one is dissociation. Correct? There are two situations: association and dissociation. Acha, guys, you have to identify where association happens and where dissociation happens. Tell me, how do you do that? How do you identify whether it's a Van 't Hoff factor question or not? First, though, you have to understand whether it's a Van 't Hoff factor question or not. So how do you identify that? When do you understand that it's a Van 't Hoff factor question of association or a dissociation question? Write it down. But how do you know that the I is greater than 1? By looking at the question, how do you know? Let's say there is a question. There is no mention. They're not mentioning Van 't Hoff factor at all in the question paper. There's a question. And the question, looking at the question, how do you identify whether it's a Van 't Hoff factor related question or not? What's the method? Anyone? Right answer is 1. Devabrat, you are correct. So dissociation, when it's the dissociation question of Van 't Hoff factor, guys, always remember it's an ionic compound. Whenever you see an ionic compound is in your question paper, guys, rest assured this is a Van 't Hoff factor question of dissociation type. And how do you understand what's an association type question? How do you understand that? They would give you carboxylic acid system. Exactly. Dimerization, that's true. But how do you understand who is going to dimerize? So according to the syllabus, only the carboxylic acid dimerizes. You would be seeing carboxylic acid questions coming. Then you remember it's a dimerization question. It's an association question. Okay. Now, what are the equations for both of them, guys? So equation for acha. By the way, if you want to know how association happens or how dissociation happens, that's a separate segment, guys. Right now, I'm going to tell you what is the equation for them. Okay. So for association, the Van 't Hoff factor equation, and dissociation, Van 't Hoff factor equation. What are they? So for dissociation, we go like acha. Before I write that, you can see here. Right, Nandita. Very good. Van 't Hoff factor is observed divided by normal. Means what is supposed to happen. So like observed is what is happening. Normal means what is supposed to happen. So this guy is ideal situation. Instead of normal, you can write ideal. And instead of observed, you can write actual situation. Right. So let's say I am giving an NaCl particle. So according to ideality, it should be acting like one NaCl particle. If I'm giving one particle, so it should be acting like one particle. But in reality, how does it like what does it show here? So in actuality, so it's a dissociation system because it's an ionic compound, guys. So how is it going to dissociate? So formula is 1 minus alpha plus in alpha divided by this. 1 is the ideal situation. This guy is the actual situation. 1 minus alpha plus in alpha. Okay. So here actual is 1 minus alpha plus in alpha. So what is this alpha over here? See, alpha is degree of dissociation. Degree of dissociation. Okay. What is n over here, guys? N is the number of particles. That means if I'm talking about NaCl, how many particles are there? It is going to break into Na plus and Cl minus. So the number of particles n would be 2 here. Right. So this is what this is. Like the number of particles will be 2 here. Okay. Now what is alpha? Alpha, they would give you the value. Okay. Most of the time they would give you the value, or otherwise they would ask you the value. Okay. Like what is the value of alpha? You know, sometimes what they do is they go like let's say they go like alpha is 80%. They can give you the values percentage. In that case, guys, you divide it by 100 and make it fractional before using it. Okay, if they give the question in percentage, guys, make it fraction and then use it. All right, don't put it in percentage in here when you are using this equation. Okay, now anyway, what about association, guys? Everything remains the same, but this n alpha becomes alpha by n. Okay, that's it. What is this n again? This n is again the number of associated particles. Earlier it was dissociated, this is associated. Okay, so for carboxylic acid system, guys, you know that you learned it in organic chemistry already. Because of hydrogen bonding, two particles associate together, right? Two particles are associating together. So here, as two particles are associating together, so the n equals to 2 here in this situation. Right? So this was the Van 't Hoff factor thing. Now, how do you use Van 't Hoff factor? So for every single equation of Raoult's law, you multiply it by the Van 't Hoff factor. So this into I, this into I. That's it. What is the RLBP? Here also. Okay. So that's how you solve the Van 't Hoff factor related typical questions in here. All right. Okay. This was the entire thing about this chapter solution over here, guys. I guess we are all clear now, right? These are the all formulas that you need to go through. I don't think so I'm missing any important formulas from here. Mostly you'll be getting all the questions from this last four formulas only, and you also know it, right? These are the most important segment. Make sure, guys, before you go to exam, you solve, at least you see some questions of Van 't Hoff factor. Watch some questions of Van 't Hoff factor, see some miscellaneous problems. You have it in your askIItians module. Tons of questions are there. On the top of it, if you need something, you just ask the faculties. Okay, they would share all those time of questions with you. Okay. So could you show the I for association, please? Yes, beta. Do you want me to derive the equation, Vaishnavi? This 1 minus alpha plus alpha by n. Do you want me to do that? All right. What do you want then? The formula. Oh, the formula. There we go. 1 minus alpha plus alpha by n this time. Earlier it was n alpha for dissociation. It is alpha by n for association. So guys, according to the question that is there in your syllabus, this n is always going to be 2. I'm talking about association because they are only going to give you the carboxylic acid systems. All right, so it's only going to be 2. Welcome. Can we use the direct formula I equals to 1 plus? Yeah, definitely, Naman, for sure. Numerical questions, na? If you get it correct, no one cares. All right. Acha. Yeah, 100%. You'd be getting check marks as well. If you just couldn't solve the question and if you're just writing the formula for Van 't Hoff factor, the right formula of Van 't Hoff factor, then also you'd be getting some marks for that. Definitely, for sure. Okay. Just guys write something. Okay, if you see that there is a completely unknown question or something, just make sure you write the formula or something in it. Okay, then definitely they would be giving you some marks on it, right? They have to. Acha. Now, one more thing, guys. Let's say you are solving a question and you didn't get the right answer, the right numerical value that you're supposed to get. Don't get disheartened. For the rest, you might lose 1 mark for that. Rest of the score you'll be getting correctly because if you are putting the right equations and everything is fine, then you will be getting marks for that, right? Now, let's come to the electrochemistry, guys. One of the most important chapters, the most scoring chapters of entire grade 12, right? So in electrochemistry, what all things that you have to be aware of, guys? First, you have noticed that the first part of this chapter is electrolytic cell, and then you have electrochemical cell, right? So if I start with electrolytic cell over here, there are some formulas which are coming from physics only. R equals to rho into L by A. Okay, formula of R is ohm. I don't have to tell you this, right? The formula and then you have rho. It is centimeter inverse. Sorry. Oh, this is ohm centimeter. Rho is ohm into centimeter, right? That is what you're gonna get the value of rho for. Acha. This L by A is also called cell constant, guys. This L by A is also called cell constant here. Okay. L should be coming in centimeter, A should be coming in area, na? So centimeter square. Correct? Right? Now, this was the formula for resistance. So guys, do you understand? This time we are talking about the electrolytic cell, not electrochemical cell, not Nernst equation, not the Daniell cell. It's the opposite one, electrolytic cell, that you have to used to do in grade 10. It's that equation right now. For G is the it's the conductance, opposite of resistance, right? So G is called as 1 by R. So 1 by R means you just reciprocal of this entire equation. So it will be 1 by rho into A by L. Now 1 by rho can be also called as kappa, which is resistivity. Conductivity into A by L. So what is kappa, guys? Kappa is conductivity. Or you can also call it specific conductance. All right. Exactly, Nandita. This is fine. Now, what is lambda? Guys, there are two types of lambda. One is lambda M, lambda E. Okay. Now, lambda is also conductivity, but this is molar conductivity. Right? It's molar. And when I'm talking about lambda M, and lambda E equals to equivalent conductance, right? It is equivalent. Now, what is the difference between these two? See here, the lambda M is given as 1000 in, guys, this part is very, very important. Okay, the 1000 into kappa by C. See here, the kappa is fine. The C is in moles. I mean, specifically molarity, I should rather say. The concentration term is molarity. Now, let's say the concentration term is not in molarity. So guys, can I write molarity as mole per liter? I can write this like mole, number of moles is on the top and then volume is on the bottom, right? So we can say moles per liter is molarity, right? Instead of mole per liter, if I want to write the same equation where the C is mole per meter cube, guys, liter means, this is liter means decimeter cube, na? So instead of liter, if I want to write this equation of C in terms of mole per meter cube, then the equation, then this equation stands like kappa by C, not 1000. Okay, so lambda M can be written as kappa by C as well. But when it is not mole per liter, when it is mole per meter cube, at that time it is kappa by C. All right, guys, understood? If I'm talking about equivalent conductance, tell me, guys, what changes in there? This is also 1000 into kappa by C, but what changes here in equivalent conductance? Here the concentration is in normality. Do we know this? This one, the concentration is in normality. Here the concentration is in molarity. Equivalent conductance is normality. Clear, guys? We're clear with this? Now coming to the next one, which is Debye-Huckel-Onsgaard equation. Acha, when do we use it? So this equation tells you how to find out the lambda M for strong and weak electrolytes. Okay. So specifically, this stands for strong electrolytes. So for strong electrolytes, how do you find out the lambda M? So that goes like lambda naught M minus A root C. Lambda naught M minus A root C. How do you get the value of lambda naught M over here, guys? From the graph. When you try to put the graph of root C versus lambda M, try to place the graph, then wherever the graph intersects with the y-axis, this particular point is called lambda naught M. Lambda naught m can only be figured out from the graphs, guys. It cannot be figured out in reality. Lambda naught m is nothing but the molar conductance at infinite dilution. Means if you infinitely dilute it, like if you just take a solution and make infinite amount of water in it, then comes lambda naught m. How do we understand this, guys? See, the concentration is almost 10 to 0. Concentration is 10 to 0. That means, guys, it is going towards infinite dilution, no? Right? So in infinite dilution, it is called lambda naught m. So this lambda naught m can only be figured out from the graph only. All right? For strong electrolytes, means HCl, KCl, salts, strong acids, strong base, for them. Correct. Now, this is for strong electrolytes. We use this equation. But what about weak electrolytes, guys? What do we do for weak electrolytes? See, if you look at the weak electrolytes graphs, it goes like this. That means for weak electrolytes, it never really touches the y-axis. So you can never get the lambda naught m. Are you understanding my point here, guys? Here the lambda naught m is useless. You can never find it. So that is when, which law is gonna come now, guys? In order to find out the lambda naught ever? Very good, Yana. To find out the lambda naught m of weak electrolytes, we go for Kohlraasch law. What is this Kohlraasch law tells you? Okay, what does that mean, guys? What is the nu plus? It is the number of cations, right, Naman? Make sure, guys, you know the definition of Kohlraasch law. Okay, they can ask you to write that down. Number of cations. What is lambda plus? This is charge of cation. How do we determine which is the stronger electrolyte in graph? From the graph you can clearly understand by looking at the graph now. Okay, but in reality, how do you understand? That is the weak acid, weak bases are weak electrolytes, strong acid, strong bases are strong electrolytes, like that. Between other strong electrolytes, that you can never understand unless and until you are keeping all of the electrolytes in the same graph. All right, let's say it's a very good question actually. So Devabrat is asking me a very good question. They're asking me, sir, let's say I have KCl and let's say I have HCl, both of them. How would the graph look like? See, Devabrat, for KCl, if the graph is like this, for HCl, the graph would be like this. Why is that? Because see, in this situation, how do you put it? Because see, Cl is constant in both the cases. So it's actually the graph is between H plus and K plus. Is that clear? Now in between H plus and K plus, who would be having greater lambda? Who would be having greater conductance? Whoever moves faster. Who moves faster? H plus moves faster. Why does it move faster? Because it is small in size. That's why his graph would be higher. KCl's graph would be lower. Is that clear, guys? Very good, Nandita. Very good. Clear? Okay, that was the entire part so far, guys. Now let's come to the Kohlraasch law. So here the charge of the cation, and then again lambda minus is the number of anion, and this is the charge of anion. Just put it in there. I mean, sorry, not charge actually. It's the conductance of cation. All the values will be given. Okay, guys. Conductance of cation. And this is the number of anion and conductance of anion. Clear, guys? This the degree of dissociation. What is this degree of dissociation, guys? You remember the alpha that we have talked about in solutions chapter. There also we have talked about it, and here also we are going to talk about alpha. How do we calculate alpha? So with respect to the conductance, you can find out alpha. What you have to do is conductance at any particular concentration. Okay, divided by conductance at infinite dilution. Okay, lambda c is conductance at any concentration. Lambda naught is conductance at infinite dilution. Okay, you divide these two values and you get the value of regular. Okay. Now, guys, alpha is specifically for weak substances. This is specifically made for the weak substances. Now, if that's so, guys, in what happened? Just one sec. My pen tab is not working. Huh. If that's so, that, guys, from the chapter equilibrium, you have learned that K can be written as C alpha square. Correct? If you know the value of alpha, from there you can find out the equilibrium constant value as well. K is equilibrium constant. So if they ask you what is the value of equilibrium constant, so first you have to find out the value of alpha, and from there multiply with concentration. It's a molarity again. It's the molarity. Multiply with it, you'll be getting the equilibrium constant there. Clear, guys? Understood? K equals to C alpha square. Just remember this equation. The original equation is C alpha square by 1 minus alpha. It's better if you can use this equation. Okay, it's better if you can use this equation. But again, if you are running out of time, always remember alpha is a very, very small quantity, so 1 minus alpha can be written as 1. So that's why I've written this equation. Okay, totally whatever suits you here. Okay, now going to the next one here. Kohlraas law is discussed already. Now, guys, that was electrolytic cell that we have talked about so far. In electrochemical cell, the most important thing is the Nernst equation. 100%, one or two questions are gonna be there from this particular topic. Correct? Nernst equation is a completely very, very important topic on its own. Now, how do you write the Nernst equation? Definitely, you know the basics, guys. E cell is equals to E naught cell minus 0.059 by the number of electrons log of oxidation segment divided by reduction segment. But before we go for Nernst equation, when do we use Nernst equation? Is there anybody who can tell me when do we actually use the Nernst equation? Like, how do you actually understand it's a question of Nernst equation? Again, when the question comes now, it's going to be the first thing that you would be kind of at that time you'd be not be able to understand from where the question is coming, which equation to use, which equation not to use. So how do you actually understand, how do you recognize that whether it's a Nernst equation question or not? Is it, Naman? Not very, Devabrat. Very good, Aditya. Aditya, you are right. Nandita, electrode potential can be figured out by cathode minus anode as well, like the self potential and stuff. So they don't really straightforward always ask you the electrode potential, right? They can ask you a cell potential. Let's say they are giving you an equation and they went like, what is the potential of the cell? So how would you understand in that situation? Potential of the cell can be figured out cathode minus anode as well. So how do you understand it's a Nernst equation question? Very good, Bhavna. Right answer. Kind of right with it. What about others? No, Naman. It's a little risky in that way. EMF experience. Acha, guys, I'm gonna tell you this, okay? Experience. Nice answer, Naman. Okay, guys, how do you actually understand it's a Nernst equation question? Let's come to that. When the concentration of solution is exactly true. Very good. And I have Nandita, EMF Daniel cell equation. Then gives. See, guys, we can give the concentrations. That's not the problem. But you have to realize it. Nernst equation question, it becomes Nernst equation question in two situations. One, when the temperature is not standard. When the temperature is not standard means when it is not 25 degrees centigrade. That's an Nernst equation question. So if they go like there is a cell which is operated in, let's say, 28 degrees centigrade, that means, guys, you be rest assured this question is going to be Nernst equation question, because that when you change the concentration, that the cell equation would change, the potentials would change, right? So that's what we are talking about here. Okay, the second situation is what you all wanted to say here. when the concentration is not 1 molar. Guys, our cell is only based on 1 molar concentration, correct? If you go for the Daniel cell, you know that the solution was of 1 molar. When it is not 1 molar, then it's a Nernst equation question, correct? We are all clear so far? Now, this is a Nernst equation. But then again, guys, in the revision classes, I have shown you which all places you can make mistakes in. So I'm going to ask you one question. You have to draw the Nernst equation for that. Let's say A gas, platinum, A gas, to A plus aqueous, salt bridge, B 3 plus aqueous, oblique, B gas. This is the cell equation given to you guys. Okay, you have to write the Nernst equation for this. What's the common mistake that we can do? I have shown you this thing situation. I have shown you this before as well, right? So what actually happens is in this kind of question, E cell equals to E naught minus 0.059. Now tell me guys, what should I write as N? What should I write as N? Come on, write it in the comments. Very good, Devabrat. The N would be 3 over here. Right, Fawaz? Right? Everyone, no, not 2, it's 3. Because whatever is the larger number of electronic transition, 3 plus 2, 3. This is 1. Now tell me guys, what am I supposed to write after log? What am I supposed to write after log? What's the shortcut, guys? You write whichever ion is first, you write that first. Whichever ion is next, you write next. Correct? Right? But is this correct? Is this representation correct? What's wrong in here? See, no dear, it's not B by A. Why would it be B by A? Ox by reduction, no? The anode is getting oxidized, right? So A plus divided by B3 plus, right? Exactly, guys. Exactly. A to the power 3 would be here. Why 3? Why 3? Because see, if I draw the equations here, what happens there? A turns into A plus electron. What about the second equation? B3 plus takes 3 electrons and becomes B. If I have to write the final equation, you have to balance the electrons over here, isn't it? If you have to balance the electron, you have to multiply the equation with 3. Then the electrons would cancel out, right? Then the final equation goes like 3A plus B3 plus gives you 3A plus B. So if I write the rate constant for this, it would become A plus cube by B3 plus. I'm not writing B and A because guys, they are not gonna be taken. They are taken as unity, right? Are we understanding this? So A3 plus B. So always remember, if the number of electrons are not equal in these equations, either you write the equations and balance it, or you balance it on your head. But guys, be aware of that part. There's a high chance of you guys making mistakes in here, right? Now, coming to the next one, which is the relationship between delta G with E cell and K equilibrium, guys. We all know that delta G can be written as minus NF E cell equals to minus RT ln K equilibrium, right? Generally, this value of R is 8.314. You can go and rest assured and write as 8.314 here. Okay. Acha, one thing that I forgot to tell you here in the Nernst equation, this equation we are very much used to writing, right? But this equation only targets the concentration changes, correct? If I change the temperature, then what will happen? I told you, no, Nernst equation can be written as temperature change and concentration change. This equation only holds for concentration change. But guys, be very good, Naman. Be very much aware if the temperature is also changed. then you cannot use this null equation. What you have to use is E cell equals to E naught minus 0.059 by, sorry, then you have to write 2.303 into RT by NF. You have to use this equation because the temperature is hiding in here, right? Very good. Those who know this, very good, guys. But we need to be very, very extra precautious about this. They can give you a non-stick equation, but they are not keeping the temperature at 25 degrees centigrade. Make sure, guys, you keep this equation, not the 0.059. Understood, everyone? Clear? Great. Now, let me check if there is any doubts in the comment section or not. Those who are watching live, guys, you can write your doubts in the comment sections, right? Now, sir, R values. So R values are, Nandita, like when it is in joules, it is 8.314. Joule, Kelvin inverse, mole inverse, okay? When you are in liter ATM, it is 0.0821. Okay, it is in liter ATM. Remember, joules and liter ATMs are divided by 100. Simple like that. When it is in calorie, it is 1.98. You can take it as 3. Liter ATM Kelvin inverse mole inverse. And here it is 2 calorie Kelvin inverse mole inverse. Right? Sir, should we reverse the sign of potential if A is undergoing oxidation? Very good point, Ridwan. Always remember, when you are solving electrochemistry questions, guys, you have to have the E cell values under reduction potential. Every single equation that we use, there the E cell is in reduction potentials. So yes, always with one, convert into reduction potential and then solve the questions, okay? And do be extra cautious, guys, about this part. Don't be so, like you have to be very, very careful at that time, okay? Don't be so excited in solving the questions that you miss the E cell values. When the question comes, guys, be extra precautious whether they are giving reduction potential values or not. If they're not, then you have to change the equations to reduction potential. Otherwise, every single formula that you know would be wrong. Correct? So will the standard electrode potential always be given? Ah, no, you don't have to remember a single standard electrode potentials. So always it would be given. And when they say it's a standard electrode potential, that's always reduction potential. Always remember that. That's the right way of giving it. So they would always, you're welcome, dear. They would always give it in reduction potential only. All right. And guys, this is your equation here. Okay. And like I was saying, Nandita, you can use these equations, these values for R. Okay. Universal gas constants. All right now. So let's go to the last chapter, kinetics, where I feel like every one of you should be able to get full marks in it. All the questions are very, very simple over here. Only one thing, guys, you have to be cautious about. There are two ways of writing the rate of the equations. I guess you have all noticed that. Let's say I'm writing an equation as 3a plus 2b is equals to 4c. This equation can be written, the rate of this equation can be written in two ways, right? So will the product of electrolysis come from? It would. It would. And that is the kind of question I was actually telling you to. That's why I was telling you to go through the NCRT back exercise. Guys, Aditya has reminded me of a very important thing here. Let's see how many of you can answer this question. What would be the product when AgNO3 aqueous solution is electrolyzed? It's electrolyzed with platinum electrodes. Tell me, guys, what will be the products? Very essential point, Aditya. Very good. What would be the product in the situation? Anyone? Only Nandita? No one else? Right, Naman. Right, Bharadwaj. No one else? How do you solve these questions, guys? You break them into ions. Ag plus, NO3 minus. It's an aqueous solution, so you have H plus and OH minus as well. And between Ag plus and H plus, who would win? Now you go back to the electrochemical series. There you remember, like we know, like potassium, then sodium, then calcium, and so on and so forth. Then hydrogen, copper, silver. Whoever comes down, he's gonna win the race. So who would go to the cathode? Ag plus would go to the cathode. Correct? Who would go to the anode? See, out of every single anion out there in your syllabus, OH minus is the one who always goes to the anode. And when OH minus goes to the anode, it goes out like oxygen gas. Correct? See, always remember one thing. Cation is a cathode is the electrode where cation goes. So Ag plus would definitely go to the cathode. It's a cation, no? It would always go to the cathode. Anion goes to anode. Correct? The simplest method of understanding. Now, let's say, guys, I change the electrode to platinum. What would you do? I mean, sorry, platinum to silver. What would you do? Come on, guys, give it a try. If I change the electrodes from platinum to silver, then what would happen? Only Nandita has answered. Not really, Dinesh. When the electrode and the solution are just the same, what happens in that situation, guys? When the electrodes and the solutions are just the same, what happens in the situation? When the electrode and the solution, electrode is also silver, solution is also silver, what happens in the situation? We learned it in grade 10 only. Come on, give it a go. Exactly. From here, silver would come into the solution and it would get deposited in here. Remember, we learned it in electroplating, purification of metals. In these two topics, we have learned it. So your cathode would get thicker, your anode would get thinner. Your anode would get thinner with time, your cathode would get thicker. Okay. This is the only two things you have to remember. These two cases that I taught you. Okay, in platinum and in the same electrode. Okay, these are the two things you have to be aware of. Coming to the kinetics now, guys. So can you repeat what you said when you went to use the non-stick equation with 2.3? So Ridwan, when the temperature is not 25 degrees centigrade, when the temperature is changed, now at that time you cannot use 0.059. At that time you have to use that equation, putting the temperature 2.303 into temperature. Okay, great, great. Okay, Abigail, you have been texting in the wrong account actually. Okay, now guys, let's go to the kinetics topic now. Now in kinetics, let's say the thing that I was saying is there are two ways of writing an equation, rate of an equation. So the rate of this equation can be written as one is minus 1/3 dA dt equals minus 1/2 dB dt in this way with respect to derivatives equals to 1/4 dC dt. Okay, one question can come from this particular topic. Okay, they can go like the rate of formation of C is, let's say, 3 into 10 to the power 8. Then what would be the rate of dissociation of A? So what would you do? dA dt is equals to 3/4 of dC dt. So whatever the value is there into 3/4 is the answer. Okay. Now, guys, for first order, the integrated rate equation and the T half. These are the two things that you have to know. So you know it is 2.303 by T log of R naught by R. What is R naught? Initial concentration. What is R? Is the final concentration. Correct? T half is equals to 0.693 by K. Now, guys, very, very important part. I guess all of you are aware of it, but still, T half is independent of R naught. Here, the T half is not dependent on the concentration at all. Correct? So be aware of this. There are different ways of asking the questions in there. And I've been teaching one of the students today only, and the way they have asked the question is completely mind-blowing, guys. They went like, T half of an equation is 30 seconds. T half of a reaction is 30 seconds when the initial concentration is 200. And T half becomes 20 seconds when the initial concentration is 50. They're asking what is the order of the reaction. Can you tell me what is the order of the reaction? By these two informations. First of all, T half is dependent on reactant concentration, so it cannot be first order. Right. Okay, Yana. Now you'd be thinking it would be zero order reaction, right? Because first it's not first order. But then again, guys, what is the equation of zero order? The equation of K is R naught minus R by T, right? If I want to write this equation in this way, then R T equals to R naught minus R by K. So what do you see? Time is proportional to reactant concentration. No, it's not inversely proportional. See here what is happening? Here it is inversely proportional. When the oh no, it's directly proportional only. Okay, in that question it was inversely proportional. So the right answer, Yana. So here you can see when the reactant concentration is more, the T half is more. When the reactant concentration is less, the T half is less. Right? That's a zero order reaction. This is the type of question they can ask. Actually, the question they asked, it was reciprocal actually. It went like 4 seconds. That would be second order. Looking at that question only, I have given you the second order equation, guys. I do know that it is not in your syllabus, but that was in a PYQ actually. It can be a mistake by the book which is collecting the PYQ. Okay, but still it was there. I haven't verified it whether it was really a PYQ or not. So I'm not gonna take any risks, guys. According to that book, it came in 2020. According to that book, guys, give it a go. Was it really there or not? Right before this session, I had that session, so that's why I couldn't really cross verify it. But as this question was there, guys, I'm gonna tell you the second order kinetics rate equation as well. It's not difficult at all. It's nothing. There is no fault in knowing it, right? So K goes like 1 by R minus 1 by R. That much, guys. This much something we can remember. KT is equals to 1 by R minus 1 by R. Here, time is inversely proportional to the concentrations. All right, this was it. Clear, guys? This is all about it. Acha, about the T half for zero order reaction, guys, it is R naught by 2K. Okay, R naught by 2K. Just look into the graphs once. First order involving gas. Guys, for first order reactions, now this is something that most of us are very prone to make mistakes in. They would be giving you a reaction like A gas is turning into B gas and C gas. All right. They would give you the initial pressure as, let's say, 2 atm. And they would give you the final pressure, or let's say the total pressure is 3 atm. They would ask you what is the, let's say they would ask you what is the final pressure. So what would you do in that situation? You would think that this is the first order reaction because the dissociation, you'd put it in the normal first order equation. But no, guys, when it is gaseous equations, and that time you have a different formula for this. What's the formula? The formula goes like K equals to 2.303 divided by T log of Pi divided by 2 Pi minus Pt. It's there in the NCERT, guys. Give it a check. Okay. This is when all of them are gases. Here Pi is the initial, Pt is the total pressure. Total pressure. Pi is the initial pressure. Okay. So Do give this type of questions a little check. All right. And now, guys, the last question is, in case of log values have not been given, what should we? You can leave the answer in that point, Ridwan. They won't cut your marks, but just remember the values of log uh, 2, log 3, log 5, and log 7. Only these four. Definitely, Aditya, the graphs are important. I'm right now. I'm talking about the formula-based question. Only the formulas right now. Huh? Graphs are definitely important. Right now, I'm just taking the formulas into consideration. Okay. Now the last one is the Arrhenius equation, guys, which is k equals to a e to the power minus ea by rt. But the questions won't come from this equation, guys. Questions won't come from this equation. Question would come from this equation. Log k1 k2 by k1 is equals to ea by 2.303 r 1 by t1 minus 1 by. This is the equation from where the questions would come. Okay, they would say when the temperature has been changed from, that rate constant only, reaction constant only depends on temperature, right? Only temperature. They would go like, when temperature is changed from T1 to T2, the rate constant changed from K1 to K2, and then went like, what is the activation energy now? So I'll find it out. Okay, always choose the value of R very wisely, guys. Okay, joules, liter, atm, and calories have different values. So look into the rest of the units in the question paper, and then you choose the value of R over here. Okay. That is what I'm saying, Shani. Like, generally, they give the values in joules. Okay, they would give all the values in joules. If they give the values in joules, then you can give the value as 8.314. If they give it in liter atm, like I shared with you today, 0.0821. This is in liter atm, correct? And in calories, it is 2 calorie, 1.98 calorie or 2 calorie. Choose the value of R very wisely, guys. Okay, definitely, Niral, I can go to the zero order as well. There you go. So this was your entire, guys, formulas. There are a little bit more formulas here and there in this physical chemistry of yours, but I can be rest assured, guys, you don't have to look into the other formulas at all. This is more than enough for you. Okay, practice 1 or 2 questions from here, some miscellaneous questions from here, and don't worry, everything would be all fine. While solving the question, guys, double check the don't make any mistakes in the silly mistakes in the calculation part. Everything else would be going pretty well. Okay, so that's my time for today, guys. Like I said, I'm always available for you over the WhatsApp, so just text me once with your doubts, whatever you need in there. All right, by tonight you'll be getting all the PDFs and all the things that I have been making so far for all of you. And guys, I would definitely tell you guys, like, whatever things are important, I have shared everything with you, and don't worry about the preparation, about your preparation. We would always feel like our preparation is not enough, so you don't have to worry about that. Okay, just make sure you are giving your 100%, and when the question paper comes, just be at yourself. Like, don't be nervous, or don't be deserted or anything. Whatever the question paper is, if there is a known question, guys, you have to fight with it, right? So you have to be at your best point in that moment, right? So don't get frightened by looking at the question paper, or don't get overexcited with it. We have to avoid the silly mistakes as well, right? So double check all of your answers in there as well. So let's keep it up to this for today as well. See you in the next class after your boards are over. Okay, bye everyone. All the best for your exams, guys. Bye.
Thank you, sir.
Welcome, dear. Bye.